Hello, good morning and good afternoon, everyone. And thank you so much for joining this monthly demo slash webinar today. I am Bhavin Shah. I'll be your presenter for today. And the topic for this webinar is an easier way to deploy highly available Cassandra and MySQL or MySQL clusters. I see we have a few people already joined in, but I'll give it just a minute, a couple of minutes maybe, before we get started with the presentation. So for people that have already joined, thank you so much for spending the next hour with us. We'll make it, we'll show some demos, keep it exciting, and have some lively Q&A. But I'll go on mute for a minute and then we'll get started in 2 minutes from the top of the hour. Awesome. So it is 2 minutes past the hour. So let's get started. Again, thank you so much everyone for joining this live webinar. My name is Bhavin Shah and I'm a Senior Technical Marketing Manager with the Cloud Native Business Unit at Pure Storage, or the Portworx Business Unit at Pure Storage. And the topic that we have for all of you today is just discussing an easier way to deploy highly available Cassandra and MySQL clusters on Kubernetes. To like guide the flow, the agenda that we have is we'll do a few slides in the beginning, maybe for 10 to 15 minutes, just set a stage, talk about why you need something like Portworx Data Services, what is Portworx Data Services, and how it provides that easy way to deploy data services on Kubernetes. And then we have a demo for you, which covers maybe half of the webinar, or if not more, and then we'll open it up for some Q&A. So it's me on the call. So if you have questions, just put it in the Q&A panel, and I'll try to monitor it as we go along. If not, we'll get to it at the end of the webinar as well. For places that you can find more information about Portworx and me, you can follow our social handles at Portwx on Twitter. You can find me on Bhavan04890, and then I also co-host a Kubernetes podcast called Kubernetes Bytes. So all good information there. With that, let's get started. Let's talk about how modern applications are being built and what are the different data services that they use today. So if you're familiar with applications or the application development lifecycle, majority of modern applications are being built using containers and the concept of microservices. And since we all know that Kubernetes has become that de facto orchestration platform for any containerized applications, Kubernetes is what is used to run these applications in production. But we have seen that this change in the way applications are being built, but we have also observed that applications or developers that are building these applications are not just using monolithic or traditional relational databases like Oracle or SQL Server. They are relying on modern distributed or NoSQL databases like Cassandra, like PostgreSQL. They're using messaging and streaming platforms like Kafka with Zookeeper. They're using things like MongoDB. So they are, and it's not just one of these different databases, right? They are using a combination of these different data services as part of their application. So if we just consider Amazon's e-commerce application, right? Like you have a different database that stores your user information, so your account information. You have a different database backend that's storing your order information, and then once that order is received, there is a streaming platform or a messaging platform like a Kafka or a RabbitMQ Kafka that is taking those events and using a PubSub model to make sure different consumers can be made aware of those events. So any application that is being built using containers is relying on these modern data services. And if we talk about what do DBAs care about, or what do database groups inside organizations, or what do DevOps administrators care about to make sure that their end users have a great experience, are things like agility. So what do we mean by agility? Agility is, as a DBA, I want to make sure that my developer gets access to a database or a data service as soon as they want, on maybe by just clicking on a few buttons or using a set of APIs. You don't want them to wait for a couple of days to a week to get access to a database connection endpoint that they can start using in their applications. Having agility means makes it easier and faster for developers to push code to production or build applications that are eventually promoted to production. So agility is obviously one key thing. The second big priority for any DBA or any organization is the cost reduction aspect that comes along with it. Cost reduction in terms of, like, okay, if you have been inside a customer organization, you know that in the past we have been tied down to a specific database vendor, to a specific infrastructure stack. And this can lead to an increased cost over the period when an application is being built to when it's running in production. And we are on the mercy of these database vendors, where if they change their licensing model, we basically have no choice but to pay what they ask us to. So cost reduction and making sure there is no vendor lock-in is kind of a high priority for DBAs these days. So if when they are looking at modernizing, right, one of the things that they are looking at is that multi-cloud approach, and Kubernetes being that uniform orchestration layer across any different public cloud or private cloud providers provides that uniform layer where your applications can be run. So people are, or DBAs are, looking at that multi-cloud model or a multi-vendor model to make sure that they can bring their costs in control as well. Third thing is around performance. Obviously, any application, it doesn't matter the role, right? If you are a developer or if you are a DBA, you want your applications to be highly performant. Since the switching costs between different applications are really low, it is very easy for a consumer or an end user to switch from your app or your website to a different app or a different website. Personally, I do the same thing, right? Like if I'm at the airport, I look up an Uber first. I don't know why I prefer that, but I open the Uber app first. And if it's taking a lot of time to find me a driver, I'll just switch to Lyft, maybe start both requests at the same time and get in the car of whichever one shows up first. So the switching cost is really low. That's why you need to make sure that the applications that you are running in production for your customers have the level of performance that's needed to ensure a smooth customer experience. This actually takes us to the final the fifth point as well, right? Just talking about customer experience. We need to make sure that our applications are performant, but we also need to make sure that they are highly available. We need to make sure that there is no single point of failure in our application stack or our infrastructure stack. So just by a node going down or a region going down, some network outage, we shouldn't, our customer experience shouldn't be impacted. Our customers should still be able to access our application when they want to. And this is something that we have to take into account when we are choosing a database solution and deploying it in production. And then finally, the fourth point that we skipped over is modernization. This is where from the top down, right? So from the CIOs all the way to the down to the individual contributors, there is a new effort to modernize your applications or modernize the way you're doing things. And this can be a spectrum. You can have organizations that are still modernizing their infrastructure stack. Maybe they are in the phase where they are thinking about public cloud, or maybe that's something that can help us be more agile. Or this can be customers who have gone through that public cloud adoption or that cloud adoption and are now looking at containerization and Kubernetes as that next level to make things easier, to make things agile even further. So modernization is always something that's on the top of the mind for DBAs as well. Like how can they keep up with the technology evolution that's happening right now? But when we talk about like what the developers or DBAs care about, there are also a few challenges that they face today, right? So the challenges, if we quickly cover them, the first one being scaling. So from a scaling perspective, okay, let's say the organization has adopted AWS as the cloud solution. They have deployed Postgres on EC2 instances, and that's how they're running their database. They're not consuming anything managed from AWS. To scale up or scale out your Postgres instance, you basically have to deploy more EC2 instances, log into your database, perform sharding operations, manual expansion of your database, and then eventually you will be able to meet the increased demand from your applications. And this is not an easy task, right? This takes, if you're an expert in the field, if you have scripted something, it still takes you some time to do it right. But if you are new to this, and if you join the new organization, you're responsible for a specific application and the backend database, you might take a week to make sure that you're testing out these changes and then only applying it against your production applications. So scaling is definitely a challenge for DBAs that we talk to. Second is operational complexity. So even though we want to make sure that our developers get that self-service access, instead of having them open tickets and us creating those infrastructure resources on the backend, we still want to make sure that even for the DBA team or even for the operations team, the operational complexity is low. So not just from a developer perspective or from your user perspective, it should be easier for you as that DBA team or as that operations team to do things in a faster and easier way. You shouldn't be spending a week worth of time on provisioning virtual machines on bare metal nodes, creating LUNs, mounting those to your virtual machines, and then manually installing databases. That just slows down the whole process and creates a lot of work for your team when they can be doing better things that contribute to the top line of the business. And this leads us to the next point, right? Product engineering execution. Like as an operations team, I know we can't use the line that okay, IT is just considered another cost center, because clearly we are past that point and it's not just considered as a cost center. But there is still a lack of focus, and there is still some improvements that are needed to make sure that your operations team is able to work with your product engineering team to make sure that they're helping the engineering team, helping your developers move faster and build those applications or build those revenue generating applications faster. So the less time you spend on operational tasks, the more time you'll have available for your team to focus on actually sitting down with your line of business owner or your application owner and building applications for you. The fourth point is build versus buy for cloud native solutions. And this is something like, again, this is a spectrum, right? You will have organizations that don't have any in-house talent when it comes to containers and Kubernetes. For them, the decision is straightforward. They will have to buy it from a vendor that's available in a solution that's available in the ecosystem. But there are organizations that do have talent inside their own organization when it comes to these modern technologies. But is this the right way to proceed? Is this the right use of the resources that you have inside your organization? Should you be focusing on building a stack in-house that can be offloaded to a third party and consumed as a service, or just go ahead and buy that? So for this particular bullet, I like to talk about the Jeff Bezos thing, right? Like only focus on things and tasks that makes your beer taste better. Like he used an example when he was introducing AWS, I think, to a Y Combinator batch back in 2007 or 2008, where he gave an example of a brewery in Europe where in early days, those breweries had to be responsible for their own power generation because there was no centralized grid. But once that grid was installed and there was an energy provider in that locality, there were still breweries that were doing all of that power generation on their own. That was not helping them make better beers, make more beers, and improve their distribution network. It was taking a lot of resources to just make sure that they can generate enough power to support their brewery. This is where you need to make that build versus buy decision. Are you spending the right time in what makes your business actually better, or you're spending time on something that can be offloaded to a vendor who, if done at scale, can do a better job at things? And then the final thing is deployment time, and this actually comes in from the fact comes in when we talk about the infrastructure layers that you have today. Are you still doing things on bare metal nodes? So it will take you a lot of time to not order and backfill those nodes. Like personally, I've heard stories where there is like a 6-month wait time to just get a few servers in any data center. I'm hoping that's not the case with any one of you. But even if you have those servers, it takes a lot of time to get it racked, stacked, cabled, networked properly, installed the right OS, configured, and then proceed. Make sure it has the storage that you need, and then go ahead and install that database. That's a whole lot of deployment time. And there is a way, like if you modernize and start using a cloud native solution, these deployment times can shrink drastically. You can go down from months to maybe a week, maybe a few days, maybe a few hours. So this timeline will actually depend on how you are choosing to do things inside your organization. And if you're thinking about containers and Kubernetes and you have joined us for today, right? I'm assuming you already know about operators. And when we talk to people for the first time around Portworx data services, the first thing that we get is, why not just use operators, right? If I want to deploy a database, why can't I just use an open source operator that's available on Operator Hub? And this hopefully this slide sends that message, right? Like, it's not enough to have an operator. If you look closely at the slide, just for Postgres you have 10 different operators available in the open source ecosystem. For Kafka, you have 4 different operators. For RabbitMQ, you have 3 different operators. And this complexity increases, and the number of operators that you have to evaluate, contribute to, maintain, and hopefully nothing goes wrong in the open source code as you increase the number of data services that you use inside your organization. So it's an M by N complexity, like M being the number of data services that you want to use and N being the number of operators that are available for each data service. So this can get complicated really quickly. You might be in a scenario where you have evaluated your operator for Postgres, but what if your development team comes and asks you for 2 additional data services? You have to go through the same cycle all over again. And then more likely than not, if you are a bigger enterprise, things that we have seen is you might have to assign at least one full-time resource to track the open source project, to track the operator, and make sure that there are no breaking merges being or taking place right now that might impact the production environment. So DIY approach possible, but complicated. And this is what led us to build Portworx Data Services as that one platform for any database. So Portworx Data Services is that orchestration layer that you need to run any data service or any database on top of any Kubernetes cluster. I know I'm using any a lot, but it's one platform for any database and any Kubernetes cluster. So you can have your Kubernetes clusters running in public cloud. So you can have EKS, AKS, GKE. You can have on-prem Kubernetes clusters with OpenShift. You can also have OpenShift in the cloud. I know that, but if you can have OpenShift on-prem, you can have VMware Tanzu on-prem, you can have Rancher on-prem, or if you haven't decided what Kubernetes distribution you prefer, it can just be plain old vanilla Kubernetes that you're using to run your containerized applications. But Portworx Data Services can basically orchestrate databases on any of these Kubernetes distributions. And we can take things like Postgres, like MySQL, like Cassandra, like Redis and Kafka and Zookeeper and RabbitMQ and deploy it on any Kubernetes cluster that we just discussed. So this list, we started with 6 different data services when we made PDS or Portworx Data Services generally available in May of this year or April. I don't remember when KubeCon Europe was, but that was when it was made generally available. But after that, we have been adding more and more data services, and we are going to continue down this path where we add more and more data services to provide you that one platform, that one single UI or REST API based interface for you to deploy data services or databases on Kubernetes. So we take all the complexity out. So the thing that we saw in the previous slide where each data service had different operators available. Now you have one operator or one way of doing things for all the different data services that PDS supports. So if we talk about the 6 higher level things, the first thing is something that we already discussed about, broader range of data services. Started with 6, now I think we are at 8 or 9. And we are going to keep increasing or growing this list to include more and more data services. So in this presentation, if you see something that you feel is missing, something that you are using internally, feel free to put it on chat. We'll take that feedback back to our product management team and make sure the next release of Portworx or Portworx Data Services, which is on a bi-weekly or a monthly basis right now, can start working towards adding that database or data service through PDS. Database as a service experience on any infrastructure. This means that you can use PDS to orchestrate data services, not just on-prem or not just in the public cloud. There are older vendors that do this just for public cloud because it's easy to orchestrate on top of cloud virtual machines. But to actually do it across any infrastructure stack, across any cloud environment is the differentiator here. You can use this solution to orchestrate applications and data services on-prem or in the public cloud with different distributions. The third thing, and this is like really important because built-in high availability, data protection, and security. What do we mean by this? So when you run PDS or Portworx Data Services and you connect it to your Kubernetes cluster, you are running Portworx Enterprise as that storage layer for Kubernetes. So this gives you high availability and replication when it comes to your persistent volume claims or PVs. It gives you the ability to take snapshots. It allows you to create backups. So that's the data protection component. Security, by security, like, okay, obviously we mean using encryption at rest and things like that. But the second thing that we wanted to highlight here is the data services that we offer in the catalog today. We run daily security scans on these images that we provide to our customers. And if there is a CVE or a vulnerability that becomes known in the ecosystem, we obviously keep track of all the different components that we have in our images. If there's a new CV, we'll make the appropriate changes, make sure you have an upgrade that's available for you to use inside your Kubernetes cluster, so you can perform in-place upgrades for data services that you have deployed using PDS if there is a security vulnerability in one of those. Next is self-service. Again, this is a SaaS service, so it is hosted. It is a hosted service, so your administrators, your DBAs, or your developers can access a single UI. prod.pds.portworx.com is as easy as that, or use a set of REST APIs to perform a database like day 0 operations and day 2 operations when it comes to databases. And then final 2 points, like obviously we just want to give developers what they want. Developers want to consume data services, not manage them. And this is where PDS delivers by giving them a connection string and a set of user credentials to start using the data service that they just deployed. All the developers are awesome and they know a lot of things about technology today, or they have to. They don't really want to spend time in learning Kubernetes as a technology if they are just focusing on building a Java-based application. This is where things like PDS can help your organization, because we can completely abstract away the Kubernetes layer. So your administrator can still be responsible for attaching Kubernetes clusters and managing them, but your developers don't need to know where these data services are actually being deployed. It's on your Kubernetes cluster. Portworx doesn't host any of that data, but they don't need to know how a Kubernetes persistent volume works and how a Kubernetes service works, where to store your credentials and secrets. All of that is handled by Portworx or Portworx data services. And then finally, this is low cost, high SLA. So PDS has a licensing model that really works really well for data services on Kubernetes. We don't charge you by the nodes you have or by the capacity that you're using. It is by the number of databases that you run. So even if you have an account and don't run anything in real time for a couple of weeks in a year, you don't get charged for that. We only charge you for the data services that you run on an hourly basis. So those are the higher level bullet points. This is a new slide that our product marketing team has built, where we talk about the business benefits of Portworx data services. So it does reduce, and this has actual customer information behind it. So reducing time to market for new apps by 50%, improving your DBA productivity by 3 times. Obviously, one cloud for any hybrid or multi-cloud platform is always there, but saving up to 75% of the cost when compared to cloud databases or cloud-based database instances. And then finally, improving the fault tolerance with that native high availability at the storage layer, which helps you reduce your downtime, reduces the recovery time, and helps you build an architecture that's AZ fault tolerance. So with that, let's focus on a couple more slides before we jump in the demo section. So we spoke about what PDS does, right? But we didn't cover like what are the responsibilities that an administrator has, and what are the different tasks a developer can do using PDS. So if you look at the admin perspective, we put our admin hats on. Things that PDS allows them to control are things like adding new users to an organization. So PDS is a multi-tenant architecture, so each organization can have different tenants. So this can be different business units, and then can have different projects which translate to like actual applications or projects run inside a specific business unit. You can have an organization, a tenant, and a project, and you can add users that belong to a specific project at a time. And then you can add your Kubernetes cluster. Again, we listed out all the different distributions that we support today. This basically allows the administrator to create regions, quote unquote, for their organization, right? So they can create Kubernetes clusters and add them to the PDS UI. And you can have clusters that are clearly labeled as US East 1 versus Europe West 2, and when developers are deploying their applications, they know which cluster to select because it's been named properly. So you can still comply with local regulations or things like GDPR when your developers are deploying these different data services. The third thing is configuring backup targets and schedules. Again, developers can just check a box which says, I want to enable backups for my database or data service. But in the backend, since Portworx doesn't want to own or control any of your application data or user data, all of this is still on the admin's responsibility list. They are the ones that are configuring these targets. They're configuring the backup schedules to make sure that you have one backup schedule for each SLA level that you have inside your organization. Finally, we have things like configuring storage options. So storage options are a lightweight solution. Like we ask you for things like what kind of file system do you want, XFS or ext4, how many replicas do you need for your persistent volume, whether you want the replicas to be spread across different nodes or not. So by just entering a few simple things in the UI, we'll translate all of these into the Kubernetes storage class configuration that needs to be deployed on your Kubernetes cluster. And then finally, we have things like application configuration templates and resource setting templates. Resource setting templates just provide you a t-shirt size for your database deployment. So this can be things like, let's say you have a small, medium, and large. Small is like 1 to 2 vCPUs as the quota and limit or request and limit for your pods. You can have 2 gigs to 4 gigs in terms of memory. Again, requests and limits for your individual database pod. And then you can have a size for your persistent volume claim as well. Application configuration templates allow you to configure things like the name. If you want to customize your database deployment in any way, you can use an application configuration template and either have key value pairs that are defined in the template itself, or you can have key value pairs where the value is actually entered by the developer when they are creating their database or data service. So this is how an administrator can customize database deployments for Kubernetes using Portworx data services. And then once the admin has done all of these different tasks, from a developer perspective, it becomes really easy. You deploy a database by filling out a simple UI or a simple wizard. You start using the database immediately because you have a connection string and a set of user credentials or credentials to use. You can enable backups either at day 0, so when you're deploying your database, or if you forgot to do it at day 0 and now you realize you have to enable backups, you don't need to open up tickets, right? Just go to the UI, find that database, enable backups, and then you're good to go. And then finally, PDS does provide you that single UI to monitor your different databases or data services as well. So using the PDS UI, you can monitor things like not just the storage level metrics with IOPS and throughput and latency, but also your application level metrics from a database perspective. So tuples in, tuples out, things like that. So those are the higher level tasks. And those are some things that we'll cover in the demo in the remainder of this webinar as well. So let's just talk about a couple of architecture diagrams. Then we'll switch to the demo. I know I'll stop postponing things. Just wanted to share what the deployment actually looks like. So the first thing that we'll cover in the demo today is a Cassandra deployment. So you can either use a web UI or a REST API, talk to our PDS control plane that's hosted at prod.pds.portworx.com. Once you ask PDS to deploy a specific database, in Cassandra in this case, we work with the agents that we have running on your Kubernetes cluster. And again, in the demo, we'll go through how you can add your Amazon EKS cluster to the PDS control plane. So you have the agents already running on EKS. These agents are what triggers the local deployment of that database. So we have operator for each data service that we support. And once this operator gets triggered, it creates custom resources, in this case, a custom Cassandra cluster. And then that basically creates a stateful set from a Kubernetes perspective with the pod count or the replica count set to the number of nodes that you selected in the UI. We also deploy service endpoints and load balancers for you to start consuming that Cassandra instance immediately. We create a custom storage class for each data service that we deploy, and this is the storage class that is used for dynamically provisioning the persistent volume claims to provide the storage that's needed by a specific Cassandra node. And then since we own the storage layer as well, we also will create replicas and spread it across the cluster. So let's say you lost one of the nodes in Amazon EKS. Obviously, EKS and Kubernetes brings up a new Cassandra node on a Cassandra pod on a different node in your cluster. But if you're not using Portworx Enterprise as that storage layer, you will still have to go through all the different requirements or all the different data being copied to this new node, to this new PV, and that takes a lot of time and generates a lot of network traffic. If you're doing this across AZs or across AZs, you will also get a huge bill at the end, because AWS does charge you for egress traffic. So, but if you are using Portworx, you already have a replica ready to go. As soon as a new pod shows up on a different node, we mount that replica to that pod, and you don't have to do any database synchronization operations. You have all the data already ready to go. So that's how storage is handled. And then from a backup perspective, when your administrator has provided that backup S3 bucket, again, in this case, it's Amazon S3, but we also support Azure Blob Storage, Google Cloud Object Storage buckets, or any S3 compatible object storage. Once you enable backups, we have a custom resource, a cron job running in that namespace as well. So at the policy that you have selected, we'll configure that cron job, which takes a backup of your database, stores it in that S3 bucket, and then helps you recover it when needed. That's Cassandra. For MySQL, similar workflow. The only difference is the architecture inside the stateful set. So Cassandra, if you're familiar with the topology and how Cassandra works, every node in the cluster, in a Cassandra cluster, can do what every other node can. They just have different hash distributions across them to store data on a specific node. But if you have a replication strategy inside Cassandra, that gets impacted. Your database entries also get replicated across different nodes. The difference with MySQL or MySQL is that you have a primary node and you have read replicas and you have a MySQL router. So basically, whenever you deploy a MySQL instance, we'll create an InnoDB cluster for you on Amazon EKS or any other Kubernetes distributions and give you that router endpoint that you can start using in your application. So with that, I shouldn't have done this. Next steps. Nope, we do have to do the demo. I can't just skimp on that. So the only reason we are doing a recorded demo right now is because there were tasks that take maybe a few minutes, 3 to 5 minutes. I just wanted to make sure we cover a lot of different things. If at any point we have questions during the call, I do have the same live environment ready to go, because the demo is something that I recorded in the past couple of hours. So we have that. We look at the recorded demo with some certain things speeded up. But if you have questions, we can switch back to the live view, look at the actual PDS instance and the same Amazon EKS cluster and answer those questions. So let me hit play. So as we said in the presentation, right, we have our control plane at prod.pds.portworx.com. Once you log in, this is the dashboard that you see. Since this is something that I have never used before, I don't have any running data services. I just see a list of data services that are available to me to deploy using PDS. But before I can deploy a Cassandra cluster, I'll have to add my Kubernetes cluster, in this case, Amazon EKS. The way to do it is just copy the simple Helm command that we give you from the PDS UI and paste it against your Kubernetes cluster, in this case, Amazon EKS. Again, this makes it really easy because this Helm chart deploys all the agents, all the operators that we need on your Kubernetes cluster, and you don't need to worry about copying kubeconfig files from your Kubernetes cluster, providing us with that information, or creating service accounts. We automate all of that deployment for you, and we make it secure. So we basically, one of the agents that we use is a teleport agent, which establishes a secure reverse proxy, a secure reverse tunnel back to our control plane. So you don't have to open up any ports coming into your cloud environments or on-prem environments. We'll just establish a secure reverse tunnel for you and make that make everything that all the calls between the control plane and the Kubernetes cluster secure. So once the cluster has been added, you can rename it to whatever you want. Again, you can name it like, oh, US West 2 PDS demo. So when a developer is deploying data services, they know where this Kubernetes cluster is running. So let's start with Cassandra. This workflow is the same for any data service that you might be using. So for example, we're doing Cassandra. So we show you a list of all the different Cassandra versions that we support. Let's just select 4.0.5. You should give it a name, because that's what we'll be using to refer to it in the future. Next, as a developer, you can select a target. So PDS demo, the cluster that we just added, is now available to me, and it shows me a list of different namespaces that are available for me to deploy my Cassandra cluster. Let's just select Cassandra-demo. And then this is where we can select application configuration templates and resource setting templates. The reason we are doing Cassandra right now before doing any of the admin tasks is I just wanted to show you that by default, we have application configuration templates and resource setting templates and storage options that are available for you to use. So you don't even have to worry about your administrator configuring these things. If you just wanted to get started today, you can do that out of the box. So let's select small heap as the app config template and small size in the resource setting template. So this means 1 to 2 vCPUs for each pod, 2 to 4 gigs of memory, and 100 gigs of persistent volume for each pod. We'll create a 3-node Cassandra cluster, and then from a storage option perspective, we'll select XFS as the file system and a replication factor of 2. And the replicas, we are selecting best effort spread. This means that even if I can't spread the replicas across different nodes, the deployment will still proceed. There's a second option where you enforce volume spread or volume group policies, where if we can't achieve that anti-affinity rule, the deployment will actually fail. So based on what you want your developers to have, you can have those options available. Once the database installation has been initiated, you can monitor it either using the PDS UI. Again, the developer doesn't need to know what Kubernetes is or how it works, or you can actually log into your Kubernetes clusters and do a watch command on the Cassandra demo namespace and see all of these resources being actively deployed. So these include things like the stateful set that we just mentioned in the slides. It deploys all the different service endpoints for our Cassandra nodes. It deploys pods one at a time. Then since this is a stateful set object, you will always have the pod-0 come online first. Only and only when it's fully up and running, we then start creating additional pods that start and adding them as part of the Cassandra cluster. So you'll see our 0-1 or Cassandra-0 was deployed first. We have one container inside that pod. Once that was fully up and running, 1/1, we proceeded to deploy the second pod, and then once the second is also 1 out of 1 container actively running, we'll move on to the third pod. So this is something that I've definitely sped up. At this point, I'm hoping I should have sped it up even further, but as you can see, we clearly are not waiting here for like more than 4 minutes at this point. So once all of your different pods are up and running, let me just skip a few seconds in the future. Once you have everything up and running, you can come back to the PDS UI, and you can see that all the 3 nodes in your Cassandra cluster are also up and running. You can monitor things like the CPU, memory, and storage utilization from the PDS UI. You can look at the configuration settings that you applied, so the heap size parameters that we selected. To just start using this Cassandra instance, you can in your application, you can copy the username, PDS, and your password, and we have the connection endpoint for you. So this is how easy it is to implement or deploy Cassandra on an Amazon EKS cluster. You didn't have to learn how Cassandra works or how Kubernetes works or how Kubernetes operators work. You can go from 0 to hero in a really short time. And you can find additional details from the UI as well. For this specific Cassandra cluster, the next thing that we'll do is exec into one of the pods that we have, and then start generating a new key space, a new table, and basically add a line item inside that table. To do that, let's go back to our EKS cluster, and I'm using Amazon Cloud Shell to just talk to my EKS cluster. I can exec into the first pod, and I'll just open a bash interactive session. Once I'm there, I'll do a node tool status command to just show you that okay, 3 nodes look good from the PDS UI, but even if you look at inside the Cassandra cluster, all the 3 nodes are up and in the normal state, so UN, that's what it means. And by default, we deploy everything into one data center, Cassandra data center, so DC1, and one rack inside that data center, so rack 1. Both of these parameters are completely customizable by the administrator as part of an application configuration template if they want to. Once that's done, let's go ahead and use the SQL SH utility and create a new key space, and then create a new table and add a line item. So to create a key space, we basically give it a name, which is dev in this case, and then we do a simple strategy, so round robin from a storage perspective, and then set a replication factor of 3. Again, since you have replication at the storage layer anyways, with a replication factor of 2, you can just choose to have a replication factor of 1 inside Cassandra if you want to. I think from what I've seen, people like to do 2 and 2. So like 2 replication factor of 2 inside the database, replication factor of 2 at that persistent volume level. Next, once we have created that key space, we created a new table, just a simple table listing users by city, and then we have a few columns or a few database parameters. Let's just add a new entry into it. I don't know who Richard Longshaft is, a made-up name that somebody from our development team came up with, and he lives in New York for some reason. So that's what we added into that new table. If you do a select star from users by city, where city equal to New York, you see that it's written. So our Cassandra cluster is fully up and running, able to read and write data. And at this point, like, you have deployed a Cassandra instance in a few minutes rather than having to wait a few days or a few weeks. So now that that's done, we'll look at one specific day two operation. Let's say my application needs more storage or needs more nodes because I'm suffering from that performance hit, and I need to perform a scale out operation. Just using the PDS UI, you can change the number of nodes from, let's say, 3 to 5, because 3 is what we started with, and 5 is where we want to end up. I can just increase the number of nodes I want in my Cassandra cluster and hit apply. And PDS takes this desired state configuration and makes my current state match this desired state. So it will take a couple of minutes for PDS to actually go ahead and provision those two new pods inside my stateful set object on Amazon EKS. But once that's done, I'll have a 5-node Cassandra cluster. And again, the connection string doesn't change, the password doesn't change. On the backend, we just perform the scale out operation without having to understand how Cassandra actually works. Like, again, personally, if you asked me to do this manually, I would have to look up the docs on Cassandra's website and perform this scale out operation. PDS made that easy for me. So this is another thing that I've sped up by a couple of minutes. So once the deployment is completely successful, we can go back to the EKS cluster and then look at the new pods coming online. So again, 2 new pods for our Cassandra stateful set will be deployed. And once both of those are up and running, what we'll do is we'll basically exec into the Cassandra pod again and run a node tool status. So the initial node tool status gave us a 3 up and normal nodes. Now it shows 5, and then it basically shows how they're distributed. All of these 5 nodes still belong to the same rack inside the same data center, and this is for Cassandra. So that's how easy it is to perform day 0 and day 2 operations on Cassandra using PDS. But now let's switch our focus and talk about the second database for the specific webinar and with MySQL. But before we deploy MySQL using the default parameters or default settings, let's put on our admin hats and we'll switch things around a bit. We will go ahead and create backup targets. We'll create backup schedules, add a backup account, and then create a new resource setting policy as well. So as an administrator, I can access the settings/backup tab. And once I do that, I can create a backup account. And this can be an AWS, Azure, Google Cloud, any S3 compatible cloud as well. Once I have added a backup credential, I can add a backup location. Again, if I just added an S3 or my AWS credential, so access key and secret key ID, I can just add an S3 bucket. But if I added an Azure credential or a Google credential, I can create those buckets as well. So I already have a couple of credentials created, but just to show you how easy it is, you select add backup credential, you select Amazon S3, and the thing that you need to provide is a unique name, your access key, and your secret key for your AWS account. Once you provide this, the credential will show up and you can use that to create new backup locations as well. So from a backup targets perspective, again, I have a couple of backup targets configured already, but I can click backup target. I can select the backup credential I want to use, the name of the S3 bucket, the region where the S3 bucket is running, and I have a new backup target that can be used by my developers. And then finally, I can create new custom policies. So I have created a policy which basically initiates a full backup every 5 minutes. And this is something that will be available to my developers as well. So now that the data protection section is done, the next thing that you can do is create those resource setting templates and application configuration templates. Once you select MySQL, you can go ahead and create a new template for MySQL, a resource setting template. So let's just click add. As you can see, we have defaults, small, medium, and large, that you can use to copy or customize your own templates. But we'll create one, we'll name it extra small, so MySQL XS. And then in terms of CPU and memory requests and limits, you can specify 0.5 to 1 for CPU and 1 gig to 2 gig for memory for my MySQL pod. And then I can just do a 50 gig persistent volume since I'm using this for test dev or demo use cases. Once that's done, I can also create an application configuration template, but again, it's a similar workflow. Let's just skip to the part where we can deploy an actual MySQL cluster or MySQL InnoDB cluster. So let's head back to the dashboard. Here we'll select our MySQL from deployment from the catalog. I can select a version that's available for MySQL, give MySQL a name, select the target cluster, which is the same Amazon EKS cluster in this case. We'll select a namespace. So again, based on the cluster that you selected, your namespace list gets refreshed. You select MySQL-demo, and then you can select the now custom application config templates and resource setting templates that you have created for your developers. So we'll keep the default one selected for app config, but for resource setting, you see I have my XS template as something that's available for my developer. Since this is a primary and a read replica, I'll just stick to 2 nodes in my MySQL cluster. And then from a storage option perspective, we'll select the same thing. We'll select the volume replication of 2 with best effort spread. Again, you can customize this even further if you wanted to. Once I select that, a thing that I'll change for MySQL that we didn't do in Cassandra is enable backups. So let's select the backup policy, the 5-minute backup policy that we saw earlier using the settings view. And then once I select a policy, I need to select where I want to store my backup snapshots. And this is where I can select the bsha-backup-bucket that's available to me. So once I select the policy, I can select a target. And once I'm happy with everything, just hit deploy. And this basically initiates my MySQL deployment against Amazon EKS again. Creates that storage class, creates that custom resource, creates that stateful set, creates those pods, services. In this case, it also creates a cron job for my backup tasks, and basically, again, automates all of this process that you don't have to do manually, automates the entire day zero operations, and gives you a connection string that you can start using in your applications. So we can look at how the deployment is functioning. As you can see, we have a cron job with the schedule set to every 5 minutes and forever, basically every 5-minute intervals. And then it deploys the stateful set with 2 replicas, primary and secondary, or primary and read replica. Once both the pods are up and running, we can go back to the UI. It shows us available as that state, and since it hit the first 5-minute mark, it automatically did a full backup of my MySQL cluster and stored it in that backup target. So you can monitor your different backup jobs and schedule backups from the PDS UI for a specific data service or database as well. So once that's done, I can click on the connection string, copy my username, copy my password, copy my endpoint, and I'll actually deploy an application, a simple application, phpMyAdmin, and provide those variables so I can access the MySQL database. So a few things that you need to update here. You can update your MySQL password. Again, this is something that gets randomly generated for you using when you deploy your MySQL cluster, and you can copy it from the PDS UI and paste it in your application file or in your Kubernetes YAML file. Once that's done, you can also update the name of the host. So basically the endpoint for your database or data service. In this case, the MySQL endpoint that you can fetch from the PDS UI. So we'll just take the first one, which is the MySQL router. So basically, it will every time point to the primary node in your InnoDB cluster. Once I have replaced it, I'll save the YAML file, apply it against the same namespace. So we'll do kubectl apply -f MySQL app and use the MySQL-demo namespace. Once that's done, it deploys a pod, a service object, and a deployment object for me. I can do a kubectl get all in the MySQL demo namespace, and I'll see that the service object has already been created. My pod for phpMyAdmin is being deployed right now, is in the container creating state. Once that's done, I can just take this endpoint, use my browser to point to it, and I'll have phpMyAdmin up and running. We log in to phpMyAdmin using the PDS credentials and start accessing our database. So I know that, and now I see that my pod is up and running. I can now copy the connection endpoint or the ELB endpoint, navigate to it, and there you go, phpMyAdmin is up and running. We log in with PDS as the username and copy the password. And that's it. Like, that's how easy to perform that day zero operation for MySQL using Portworx data services. One more thing that I wanted to show in this demonstration, I know we are getting closer to the end of this demonstration or this webinar. So again, start putting your questions in chat and we'll get to it. once this demo is wrapped up. So to start with, we only had access as that resource setting template, right? We create a new template called MySQL small, and we have better CPU and memory resources for the pods or cluster that use a specific template. So for Cassandra, we performed a scale out operation. Now for MySQL, we'll perform a scale up operation. So we'll basically edit our MySQL cluster once this backup is successfully done. So again, every 5 minutes, you will see that backup job basically taking a full backup of your MySQL cluster. You don't have to be as aggressive, but if you want to, you can. Once that backup is succeeded, let's click on edit, and I can select a different resource setting template. So instead of excess, I'll select small. The only thing to note here is we'll change the limits, requests and limits for CPU and memory. We won't actually change the persistent volume size through this setting template. That there are other ways to do it, not just through this UI. So once it's done, we do a rolling upgrade or a rolling restart of your pods for your MySQL cluster, and bring them online with these new resource limits and quotas in place. So it will go into partially available because one node at a time is down in your MySQL cluster. But once both the pods are available again, your application or database will become fully available, and you can continue accessing it as part of your application. So that's how easy it is to perform data protection and data operations like scale up and scale out using Portworx data services as well. I think that's all the demo I had. As you can see, I only have like 10 seconds remaining for this application to be fully available. So let me just show you that at the end it all works out. Happy ending. And once both the pods are up and running, it has those new limits in place. Instead of 2 gig limit across 2 pods, I now have 4 gig as the limit across 2 pods. So that's how we perform that scale up operation. Let me switch back to the slides. And now I think we can talk about the next steps. So talking about next steps, if you like this demo, if you want to find out more about Portworx data services, we have our documentation site, our product website landing page, all linked here. We have linked to our blogs and our YouTube channel where you can find more blogs around not just how to do MySQL and Cassandra, but also do things like Postgres and RabbitMQ and Kafka with Zookeeper or Kafka without Zookeeper on any Kubernetes cluster. You can find, if you really like Portworx data services, you can hit the contact sales button, and we'll have somebody from our sales team reach out to you and create an organization and a tenant for you, and you can start using PDS today. But with that, that was my last slide. Thank you again, everyone, for joining this webinar. I hope you learned something new, and this was really helpful for you to understand how data services on Kubernetes can be made easy. But at this point, I think I'm done with the regularly scheduled agenda. Let's just see if you have any questions. If not, if you don't have any questions till this point in chat, please start adding those questions. We have 8 minutes remaining till the top of the hour where we have to close this session, but we can answer some questions till that point. Okay, I don't see any questions. Again, we did share some social media handles. You will get a follow-up email because you registered for this webinar. If you have any questions, feel free to reach out. If any of you are traveling to KubeCon next week, see you at KubeCon in person. And until then, like, have a great rest of the day. Thank you so much for joining us.